Hello. In this simulation, Dr. Alexey Petrovsky, Dr. Nikolai Kazantsev focus on non-pharmaceutical interventions into healthcare system, such as emergency production readiness for the next pandemic response based on the UK historical data from the COVID-19 pandemic. The objective of this study is to identify the optimal production strategy to address the emerging pandemic needs with respect to the number of infected individuals, hospitalized individuals, and the economic cost of pandemic. For this purpose, we developed a system dynamics model for the virus variants and 4 policy levers: masks and other PPEs, including test kits, vaccines, diagnostics and therapeutics, intensive care equipment, healthcare ventilators, and lockdowns with variable severity and strength. We focus on the early stage of pandemic. So, for example, for COVID-19, it was from mid-February 2020 to the end of November 2020, altogether 41 weeks. And the starting point is when WHO announced that pandemic begins. Now I will share the screen with the system dynamics simulation, and I will guide you through the model, showing how we achieved specific outcomes. So the first task was to replicate historical data using simulated models. So for that purpose, we established a so-called historical mode, historical scenario that replicates what happened during the first 41 weeks of pandemic. So you see on the dashboard, historical mode is on. We have the first one, original type of virus. In the UK, masks were not used at that time. And on the right side of the screen, you can see the total result of 41 weeks. So on the left side, these are the historical data which are put here to compare with our experiments. On the right side, you will see the variable data, which corresponds to the millions of infected, the number of perished, and the lockdown cost. So I'll quickly walk you through graphs. So the left one is very well known. It's infected active cases, so number of people per week. You see here, so from the 1st to 41st week. And on the right side, you see 4 supportive graphs: transmission rate, the famous R number, which was usually shown on BBC. And then we have seasonal factor. This is when infection goes down during summer months. Then the completeness of lockdowns, which we'll be working on later on, and the trustworthiness to recommendation. Further on, you might see the panel for adjusting 3 lockdowns, because historically there were 3 lockdowns in that period. Then the graph of unfortunately perished people, also per week. And supporting graphs here are hospitalized, the number of hospitalized in intensive care units, so requiring ventilators, hospital occupancy rate, and ICU occupancy rate, which are very important characteristics for quality of treatment. Finally, we have the area with vaccination. So during COVID-19, vaccination started approximately 1 year after pandemic was announced. Currently, there are plans to do it in 100 days, and improving production of ventilators. So also the number of ventilators we can produce extra to support intensive care units. So the final graphs are about the number of vaccinated and the number of recovered. So again, if we're talking about the first 41 weeks, there was no vaccination campaign. As you see, there's 0 vaccinated. At the same time, some people got recovered, and it is also replicated by the last graph. So in order to in order to go further, we need to switch off the historical mode. As I mentioned, historical mode takes the real data coming from the past pandemics, which we sourced from academic papers, peer-reviewed papers, policy reports. And when we disable the historical mode, we see now we have a new red chart, which is different to what happened in the real life, because we have now we stepped into unknown. We are now simulating, we are changing parameters of the model to the extent we like. So we have 4 policies here to play with. The first policy considers masks and PPEs. So masks availability, as I mentioned, was masks were not available for the first weeks of COVID. There was a clear government suggestion not to wear masks because there was no clinical evidence. So therefore, that's the first lever we actually can apply here. So by changing the mask availability, we reduce the number of infected people. You might ask me why the graph doesn't change. Simply because we have lockdown switched on, so that we can switch them off so far. And we see that the graph changed again. So now we see that if we remove masks completely, we see a huge spike of infected people on the 11th week. So basically, that's actually what led to lockdown. So let's put, for example, something around 80–85%. So we see already that the graph shows quite a different outcome. So the number of infected people grows slower than in the real historical COVID-19 case, which is replicated by the blue chart. So at the same time, we can check transmission rate. Transmission rate is sometimes 1.5 times less than it was in the real life. So it's the first policy. Second policy is related to vaccination. As I mentioned, currently there is CEPI announced 100 days plan. So in 100 days, we should have vaccination ready. And this vaccination is currently put in place. So 100 days, it's basically 3 months and 3 months and a couple of weeks. So basically, it's around this number of weeks, right? So, for example, we can put 10. Here we see the number of vaccinated people weekly. So, and the rate of increase of vaccination, which were feasible numbers based on how COVID-19 was treated when the vaccination started. The third policy is related to ICU capacity. It helps us to add the number of ventilators and reduce ICU occupancy rate. So, and that affects mortality, which is also important, one of the important graphs. Finally, the fourth policy is lockdowns. So if we see that we managed actually already quite well, we already managed to reduce the number of infected. We managed to, here you can see the number of infected people is 3 times less than it was in real time. And the number of people who perished is also, you see, three times less than it was, 2.5 probably. And there is 0 lockdown cost because lockdown was not imposed. So we can still put lockdown on. For example, somewhere around 16th week, we can try to do it. So let's try to do it. So 16th, and you see when I switched advanced setting on and all of the lockdowns, the slope immediately went down because we imposed lockdowns. But the whole idea is to reduce severity and reduce duration of lockdowns if possible. So let's try to impose lockdown only when we think it can be needed. It was around 16th week, and let's make it maybe slightly earlier. Again, we're checking how graph behaves. Can do it for 3 weeks. And I just switched off the second lockdown, and I switched off the third lockdown. Now we see only very small spike here, which is probably acceptable. So you see, we by imposing a small lockdown, which was a bit costly, but still we managed to reduce the number of infected massively, and we almost avoided people who perished from COVID-19 or from the future virus. And talking about future viruses, this simulation allows you to test several options. We have Alpha, Delta, Omicron, which are historical data, and also we developed disease X variant, which is completely unknown, currently discussed at the World Economic Forum, and how we made data for it. So we took the mortality of original variant, and we took transmission of Omicron. So as we know, viruses becoming less dangerous over time, but they become more virulent. So we took actually both extreme parameters to simulate this disease X. So let me put it, and we see immediately we got a huge spike because of that. And now we think, what can we do? So we already use mask for quite a good extent. So we have lots of so vaccination program is in time, but we have huge problems with immediately because so many people got into the hospitals. Let's increase the number of ventilation as much as we can, and then possibly we need lockdowns here. So the first lockdown obviously is too short. We started reducing number of affected people, but then immediately it went up because it's only 3 weeks. So let's increase it. Probably it's too much. We can start it slightly earlier, because actually it started growing at the probably 3rd week. We start from the 6th. Right, so this looks fine. Now we have from 16th, we have another lockdown. So let's put it from the start of 15th week, and let's make a duration of, currently it's 5. It's more or less helps. And then we have another spike coming from 26 week 26. Again, we'll probably start with 25 and make it duration of 4. Now we see that because the graph changes, dynamically adjust the scale. So now we managed to leverage the second and the third spike, but we still have to think about the first one. Possibly we can start earlier. That is probably the reason. Yeah. So now we see. Okay, let's make it slightly larger here. And the third one. Yeah. So you see now that what is interesting at a particular moment, that the blue graph is the historical COVID. Now we managed to simulate much more disastrous, very virulent disease X, which actually is getting through the system with a better outcome than the historical COVID. So actually, by applying for policies from masks till lockdowns, we were able to respond to much more dangerous virus than COVID-19. And even if you see the numbers, we see we have achieved less mortality here, less infected, and the slightly more costs in terms of lockdowns, because lockdowns were longer than in the case of COVID-19. Thank you very much for your attention. I hope you enjoyed this short presentation. I'm looking forward for your questions.